Throughout American history, our nation's buildings have been in a constant state of evolution. As various technologies advanced over the years, buildings in the United States have grown taller, stronger, more spectacular, and more efficient. Sustainable or green buildings represent the latest evolutionary step. Energy efficiency is often a core component of sustainable building.
Probably the most exciting thing that is moving forward right now is energy conservation, energy efficiency. And I think we're going to see that in a lot of the existing buildings all over the country and actually in a lot of parts of the world.
Politically speaking, I think to the degree we can make the United States more energy self-sufficient, I think that bodes well better for our future than the situation that we're currently in.
Energy has become an issue of global concern. In the U.S., energy issues are linked to numerous matters affecting both the economy and the natural environment. And the state of both the economy and the environment directly affect us all as individuals.
One of the major components of becoming energy independent is to build buildings which are energy efficient, because buildings use like 60% of all the energy in this country.
Coming up, we'll explore some of the many ways green buildings address energy efficiency. The number of energy-efficient, sustainable buildings is on the rise in the U.S.
We have absolutely accelerated at the most rapid pace imaginable with the square footage of LEED projects.
LEED buildings are very complex buildings on the surface, but in many ways when you drill beyond the regulations and the approach and the criteria for LEED and boil it to their simplest forms, it's really not that complicated.
We're really on board with the LEED process. We actually believe it's moved the building industry into a new realm. It's made green design more mainstream.
Also coming up, we'll check out a number of green projects in southern Nevada that are taking advantage of advancements in renewable energy. Nevada is the #1 state in the nation in solar watts per capita and solar as a percentage of retail sales.
One of the best things about our climate is we have 360 days of sun a year. I mean, there's not many climates in North America that have that opportunity.
Our first green stop is at the Vegas PBS Educational Technology Campus, where nearly 12 months of work has taken place on site. The Vegas PBS Educational Technology Campus will be extremely energy efficient. The campus will use an estimated 35 to 40% less energy than a traditional building of its size. It will make use of both geothermal and solar power. The solar system being installed on this building's roof is the largest array on a single building in the Southwest. These solar panels are expected to deliver more than 15% of the building's electricity needs. This solar system is being installed by a local company, Bombard Renewable Energy.
Well, up on the roof here where all the solar modules are, all these are sun power modules. They're rated at 230 watts. Together the entire system is 181 kilowatts DC. That's the max potential of the solar panels. The actual estimated output of the system is about 160 kilowatts AC. This is a ballasted racking system. One of the important things about that is there's no roof penetrations. It's completely weighted down by paver stones that keep the system in place. It's interlocked, so each module kind of takes advantage of the next module's weight to keep the system in place.
This solar system will earn the Vegas PBS Educational Technology Campus 3 LEED points.
Well, this system design was primarily focused around obtaining LEED points, so the Vegas PBS building could go gold LEED certification. Overall, it's going to produce probably 15 to 17% of the annual demand for the building. That's about 300,000 kilowatt hours per year.
All of this solar power will be consumed on site, but eventually some power could be fed back into the utility grid. From inside the converter area, we learn how this solar system actually functions.
The solar modules up on the roof are put together in about 10 modules per string. There's 790 modules on the roof, so there's 79 strings. All those strings are combined just above the inverter here, and then they're fed into the inverter. The inverter takes the power from DC that the solar panels produce and converts it to AC power that can be used here on the building or fed back into the utility grid.
The benefits of the campus's solar system range from economic to environmental.
One of the first economic benefits is you're getting some value out of the available roof space that would otherwise be used for virtually nothing. The real value is offsetting kilowatt hours. So you're producing your own power and not having to buy that power from the utility.
The roof of this building also incorporated other sustainable elements. In addition to accommodating the solar panels, the roof is white in color, which reflects heat off the surface in order to reduce cooling costs.
We use a white roof system which has a documented emissivity of 0.9, which means it's reflecting 9/10 of the sun's heat away from the building, instead of penetrating the building's mass where it has to be cooled.
The roof is also designed to manage rainwater. The design allows water to move toward a drainage system where it is collected underground and then dispersed slowly, which significantly reduces pollutants in the water. 10 miles from the Vegas PBS Educational Technology Campus is another green building that boasts many of the same eco-friendly features. The Cashman Equipment Company headquarters in Henderson, like the campus, has geothermal power, recycled structural steel, daylighting, and excellent indoor air quality. Cashman Equipment Company received LEED Gold certification in September 2009.
Cashman Equipment has been in business since 1931. We came into being with the building of Hoover Dam in 1931. My late husband's grandfather had a friend in that construction job who wanted to get tractors for that, and that was the advent of Cashman Equipment Company. So we've been through 3 generations, and for the last 13 years I've been heading up the company.
In 1981, Cashman Equipment's new Las Vegas facility opened, and it was expanded in 1990. A few years ago, an eminent domain issue forced the company to seek out a new site location.
This opens up a whole new chapter in Cashman Equipment to greatly expand our services, to provide a more employee-sensitive or a more employee-friendly environment, a working environment that I think they can take a great deal of pride in, be more productive. I really dislike wasting the natural resources, and if we can create the employee-friendly environment, be more responsive to our customers, and preserve all the things that we have available to us to the greatest extent possible, I think that's great.
The new Cashman Equipment headquarters is approximately 300,000 square feet on 53 acres and incorporates numerous sustainable attributes such as a ground source geothermal system to heat and cool the facility.
So what we have here is the central pump room for the geothermal system, or the ground source geothermal system. We've got 66 miles of pipe all underground coming up into this particular room, and then pumps are going to distribute it from here to each of the buildings, and that's what we're going to use to heat and cool the project with.
This ground source geothermal system provides a 5-to-1 energy payback. For every 1 unit of energy entering the system, 5 units are extracted for heating and cooling the buildings. This project also incorporated a variety of recycled structural materials, like steel containing recycled content.
So over here we have got just one of our typical structural members that we have throughout the entire project. And what we did at the very beginning is we worked closely with our steel supplier, and this is 75% recycled material. All of our buildings, in addition to having the concrete skins, they have the structural steel supply. So I've got 15% in my walls, I've got 75% in all of the structural steel throughout the buildings. It all adds up.
The concrete used in this project included a recycled material called fly ash.
This is a concrete panel, and the entire project is made up of concrete panels. I've got 8-inch thick slabs, I've got 10-inch thick panels, and fly ash is added to these. And fly ash is a byproduct of power generation. It comes from coal plants, and typically you can be 5 to 10%. On this particular project, we've got 15% fly ash added, and that's a direct replacement for concrete.
The addition of fly ash into concrete actually improves its strength, segregation, and ease of pumping. Millions of tons of fly ash are produced by U.S. power plants annually, much of which is dumped in landfills. The new Cashman Equipment headquarters incorporated numerous people-friendly elements into its design. For instance, a practice called daylighting.
We're allowing for a maximum amount of light to enter the building, but in order to do that, you have to balance the light along with the energy gain that you get from the sun. So in order to control that, we've got very high efficiency windows. We've got low E coatings, we've got shades that are going to open and close automatically with the sunlight.
Daylighting reduces the need for interior lighting, which will cut down on energy costs. Exposure to natural light has also proven beneficial to the health and productivity of building occupants. Another people-friendly element in this project relates to the sealed ductwork throughout the buildings.
So one of the things that you'll notice is all of our ducting is closed and sealed off. This is in accordance with the Indoor Air Quality Management Plan. That's a requirement for LEED.
Sealed ducts prevents dust and debris from settling in ductwork, which will help keep air clean for building occupants. Maintaining LEED compliance requires careful attention to details.
What most people do, they hear LEED, and if they don't understand it, they either exclude it or they throw money at it. And it's really our job as a general contractor to educate or demystify LEED so people understand it. It's really not doing anything much different than we normally do. It's just doing it smarter.
The new Cashman Equipment headquarters officially opened for business in February 2009. We're headed back now to check in on progress at the Vegas PBS Educational Technology Campus. This building's development team has been working together efficiently and effectively for 13 months. The team, which includes everyone from the architect and mechanical engineer to the site manager and construction crew, must continually communicate with one another in order to remain in compliance with LEED throughout the construction process. Our next stop is at a location that knows a lot about both teamwork and energy efficiency, Nellis Air Force Base. Screeching jets, fighter pilots, environmental stewards, check, check, and check. In recent years, the U.S. Air Force has become a leading purchaser of green power in America. This includes renewable resources such as wind, geothermal, and solar power. On December 17, 2007, North America's largest solar photovoltaic system opened at Nellis Air Force Base in Las Vegas.
To all of you, good morning, and it's a great honor and a great privilege for me to be back at the home of the fighter pilot and to be now at the home of the largest photovoltaic generating system in the United States.
The primary mission of Nellis Air Force Base really starts with the Nevada Test and Training Range north of here. 3.1 million acres. Almost all the Air Force comes here. We do 75% of our live ordnance bombs that are dropped in the United States are dropped here north of Nellis. The second big thing we do is, you can almost call it like a master's or doctorate level in fighter tactics and training. So pilots that have been in the Air Force for 6-8 years, where they come here and go through weapons school, and you get all the advanced training, all the advanced tactics, the advanced fighter techniques that they will employ in wartime.
The Nellis solar power system is reducing carbon dioxide emissions by approximately 24,000 tons annually And the system is saving the Air Force an estimated $1 million per year.
Yes, it's 14.2 megawatts in size, but what that means is it's going to produce over 30 million kilowatt hours of power a year. That's about 25 to 30% of the base's annual need.
All of the power produced by this solar photovoltaic system will be used at Nellis Air Force Base.
A photovoltaic array is a classic solar cell like what you see on your calculator. It converts sunlight and light directly into electricity. And those solar cells are made of silicone just like the ones on your calculator. And they're going to convert, they have about a 20% efficiency, 20% to 17% efficiency rating depending on brands of converting sunlight directly into electricity.
Those solar cells come together in a panel. Several panels joined together become what's called a tracker.
And what that means is it's going to track the sun throughout the day, and that maximizes how much power we get out of the array.
There are over 5,000 trackers, each with 12 solar panels on it. There are a total of 72,416 panels.
What they do is they take the power, it all comes in as DC. That means it's not like the power coming out of your outlet. Your outlet is AC, so you've got to convert it from that DC power to AC power. And you have an inverter that it comes into, and it converts that power. And then once it's converted, basically it's connected directly to the base power grid, and we receive power directly from the solar power system.
The solar power system covers 140 acres, 33 acres of which is a capped landfill, essentially unusable land. This project is a partnership between the base, the state of Nevada, NV Energy, and private industry.
Because without the portfolio in the state of Nevada, this would not have been possible. Without Nevada Power's desire to buy those RECs, this would not have been possible. And without private industry taking an interest and really pursuing the project, it wouldn't have been possible.
Nellis Air Force Base is involved in numerous other green initiatives such as energy and water conservation.
We've pulled almost 20 acres of grass that we used to have that would water and try and take care of. So we've reduced that.
Nellis Air Force Base has received considerable recognition for its eco-friendly efforts. The base was the first to receive the award Best in the Air Force for the installation of an energy program. It has also received recognition from the Environmental Protection Agency. And perhaps most importantly, Nellis is decreasing the service's reliance on fossil fuels and saving taxpayer dollars. It's now 14 months into construction on the Vegas PBS Educational Technology Campus. In this room, we can see where rows of server racks are being installed. The servers will eventually perform a number of critical functions, including program distribution, archiving, sharing, automation control, system monitoring, production graphics and content, and video streaming. If we look up to the ceiling, here we can see what looks like an open shaft. This shaft will eventually be fitted with a solar tube light, which allows light into the building's interior, thus cutting down on lighting needs and reducing energy consumption. Large office buildings like the Vegas PBS Educational Technology Campus are generally filled with an array of electronic devices, from computers to vending machines. These devices create what is called a plug load. Plug load equipment often accounts for more than 20% of electricity use in offices. The campus's development team implemented numerous methods in an effort to reduce the building's plug load, including limiting use of personal items that would add to the plug load and utilizing Energy Star approved electronics. Additionally, the facility's computers are extremely energy efficient.
The computers that are going to be included in this building, they will meet all energy standards by European standards. They're much more efficient than the computer systems that are allowed in the United States systems.
The campus's computers are also on timers, which send the computer into standby mode when not in use. Standby mode uses less energy than when computers are on. These computers are also eco-friendly because the majority of their components are biodegradable. Another way the campus will conserve energy is by incorporating efficient transformers into the building's electrical systems.
These take the voltage that comes in from the utility, which is typically 480 volts, and steps it down to a voltage that's usable by things that plug into the wall. That's what transformers do.
These high-efficiency transformers minimize energy waste while offering both financial and environmental benefits.
That reduction in energy waste actually provides a contribution to how many lead points are available in the optimized energy performance calculation, which is part of the energy and atmosphere portion of the lead document.
These transformers are generally between 4 and 6% more efficient than their traditional counterparts.
What that equates to overall for the entire building is about 1 to 1.5% reduction in electricity.
Meters were installed that will read all the different electrical loads of the building, from air conditioning and lighting loads to receptacle loads.
We're actually able to monitor the exact usage and see and verify whether or not the actual consumption is closer to what the engineer designed or what it would have been if they had done nothing.
Based on the building's energy-efficient elements, its actual consumption of electricity should prove to meet and possibly exceed planned projections. Like the campus, energy efficiency was an important element in planning for the next green building we're visiting, the Mulaski Corporate Center. The Mulaski Corporate Center, which opened for business in 2007, is one of the largest Class A office buildings in southern Nevada to receive LEED Gold certification.
The Mulaski Group of Companies is a multi-generational, family-owned company. It's been doing business in southern Nevada for over 55 years, and our chairman is Erwin Mulaski.
The Mulaski Group of Companies is involved in real estate development and management in the southwest United States.
The Mulaski family has built a lot of firsts in Las Vegas. The enclosed mall, first enclosed mall in the state, the Boulevard Mall, first luxury high-rise project in town, and many other firsts.
Another first, the Mulaski Corporate Center was one of the first buildings in Las Vegas to receive LEED Gold certification. It is a state-of-the-art campus that will consume approximately 37% less electricity and 30% less water than similar non-LEED certified buildings. This facility incorporated numerous innovative sustainable elements, such as utilizing 98% recycled steel, using insulation derived from recycled blue jeans, and installing ultra-low-flow urinals. In addition, this building actually sits on a brownfield site. A brownfield site is considered to be polluted, unusable land. The building also has a relatively unique HVAC system called the Underfloor Air Distribution System.
Typically in the past, these were only used in computer rooms to provide very pure air for computer systems, minimize static and increase air quality. That's being used in the occupant space of this building in the 10 floors of office.
Building occupants will benefit from this clean, healthy air. The Mulaski Corporate Group has pioneered a number of Las Vegas firsts over the years, and it continues to do so today. The LEED Gold certified Mulaski Corporate Center now serves as an example to other green projects in Las Vegas, and the number of local green projects is on the rise. Worthington credits this increase to the commitment of area business leaders.
I think we have leaders in this community, business leaders, that have taken risks. The Mulaski family is an example of that. Going after LEED Gold certification for a spec office building is highly unusual. But also you have casino leaders here that have decided to pursue LEED certification of major gaming properties. So I think that Vegas has a can-do attitude. It's got progressive leadership. You look at the Water Authority and what they've done with the Las Vegas Springs Preserve, it's absolutely amazing. Part of that campus is LEED Platinum certified. To see projects like Project City Center going for LEED certification is very admirable. It makes a big difference to the people that are in those buildings and to our community in terms of furthering sustainability.
I think as human beings we have an obligation to leave the planet a little better than we found it. And that's a good step in the right direction in order to accomplish that, to go green, to make it sustainable, to make sure that future generations will have as good a lifestyle as we have today.
It's now 15 months into the build. From the outside, this building looks nearly complete. But inside, it's a hub of activity. Here we see work taking place in one of Vegas PBS's production studios. Buildings are some of the world's greatest energy consumers. Throughout this show, we've seen some of the many ways green projects across the valley are conserving energy. We've also observed 3 months of progress on the Vegas PBS Educational Technology Campus. On the next Building Vegas Greener, work wraps up on the campus and we watch as the building opens for business. We'll also see some of the sustainable elements going into Clark County's public schools, and we'll visit the LEED Platinum certified Villa Trieste housing community in Summerlin and UNLV's LEED Gold certified Greenspun Hall.